right, Erica and Claire, this is the last bit of the Chapter 6 review. I'm going to run through with you what I just told the rest of the class. Then we're going to finish this chapter review today. We've got to do all of these, guys. I don't know why this is crossed out. That shouldn't be. We're going to finish this chapter review today. Tomorrow, I am gone, and some of you guys are gone as well, and that's for FFA, but I am going to put whiteboard problems on a video for Google Classroom. You must watch that because that will really, really help prepare you for the test. And you guys will take the test on Wednesday because juniors and seniors don't leave until the afternoon. So you're going to be taking tests over Chapter 6 on Wednesday. Make sure you're prepared for that. I am gone tomorrow. So just so you know, make sure you're ready. All right. And then Thursday we'll start like an intro into Chapter 7. Okay. So that's kind of the order of how things are going to go. We're going to finish this review together today. Here we go. Starting with number 1. They wanted to work from the front to the back. I told you to do number 3 and 4 for like homework, whatever. But number 1, let's start with number 1 and then we'll check 3 and 4. Write it in decimal form. So it is already in degrees, but it's in degrees, minutes, seconds, right? So when I do the final decimal, I know 43 is going to be my big decimal, and then I'm going to have like 4 decimal places after that, right? How do I figure out from the 3 and the 56 what my like thing is on the end of it? 3 gets divided by 60, okay? Because this is in minutes, right? How many minutes are in an hour? 60, okay? And then I'm going to add to that. This is in seconds. How many seconds are in an hour? 3,600. So figure out what this guy is. Add that to whatever this guy is, okay? Do those real quick. And tell me the 4 decimal places off the end of there, what you get. This is something that you're going to have to remember how to convert for the test. Okay? Remember how to do this.
So
0.06 what?
56.
Okay? We'll go 4 decimal places. 4 decimal places. So 0656. We'll go that way. Okay? Did anybody not get that and not know why? Okay? All right, there you go. And this is technically still in degrees, right? Still in degrees. Like we're still doing the same units, but we're doing it in decimal form rather than degrees, minutes, seconds. Okay? So that is 43.0656 degrees still. Okay? Number 2, this is in degrees, but they want it in degrees, minutes, seconds rather than the decimal form. So I know my final answer is going to have that 10 pulled off the front. This is 10 degrees. I have to figure out how many minutes and how many seconds, okay? All right, so the 0.5625, what do you do with that first? Rather than dividing by 60, right? That's what I did first here. I'm going to do the opposite. I'm going to multiply by 60, okay? What does that become? 33.75. Okay, now what do I do with that?
you take the 0.75 times 60.
Okay, so 33 is going to go for my minutes, right? 33 gets pulled off the top. Then I just take 0.75. You have to retype it into your calculator. And what do you take 0.75 times?
60.
Not 3,600 like we did over here. It's very, very tempting to do 3,600. But the deal is you take it just times 60 because this 75 was basically embedded, that 75% or 75 was embedded into the first number, so it has already been taken times 60. Do you see how that works? So when you take them times 60, that should be what, 45? Okay, and that's your seconds, 45 seconds. So rather than dividing by 60, divided by 3,600, you're taking it times 60 times 60. Make sense?
Yeah.
One you're multiplying, one you're dividing, okay? But there are a couple little weird changes. Can you remember that for the test?
Yeah.
Okay, that's not that hard. Okay, try to figure that out. Okay, 3. We are finding the 6 trig ratios, which is sine of theta, cosine of theta, tangent of theta, cosecant, secant, and cotangent. All right. Okay, theta lives in the bottom left corner, right here. I don't know if you can see him very well, but there he is. Okay, they give you 4 and 7. We need to find the hypotenuse. 4 squared plus 7 squared equals c squared.
Square root of 65.
Okay, 16 and 49 is 65. So c squared equals 65 and the square root of 65. We're just going to leave him as the square root of 65, okay? When we do this, don't convert him to a decimal. No decimal numbers, and rationalize when you have to, okay? Do you know what I mean by that? Okay, so I'm just going to go ahead and label. If this is my angle, which one's the opposite side? 7. What's the hypotenuse side? the square root of 64, and this is the adjacent side. It's going to stay that way the whole way through, so I might as well label it on the triangle. Okay, so there's that. Let's go ahead and do sine is OH. So 7 over the square root of 65. Okay, now I need to multiply by the square root of 65 over the square root of 65, which should be 7 squared to 65 over 65. Could you guys do that in your head? Yeah, basically. Okay. Now, when you do cosecant, you can flip that, but I would not flip this one. I would flip the original, right? If you flip the original, square root of 65 over 7, right? If you flip this one, you'll have to rationalize again. Does that make sense? Like, that would be stupid, okay? So, flip the original, and there you go. All right? Cosine is AH. That is 4 over the square root of 65. Or 4 squared to 65 over 65. You guys can do that in your head. If you need to write it out, like we did up here with the 65, go for it. Secant, if I flip this one, square root of 65 over 4. Make sure that you're not putting any decimals in there. I don't want to know what the square root of 65 is as a decimal. I want the ratio. Okay, they say ratios. That means the fraction. All right, and then tangent's the nice one. OA. 7 over 4 or 4 over 7. There you go. Make sense? Mm-hmm. Got it? Yep. Perfect. All right. Now moving on. Number 4. Do they ask for all 6 of them? No. They ask us to find one. So find the length of side H. Given that angle A is 50, label him 50 degrees. And the distance from C to A is 20. So this side right here is 20 units, whatever it is, right? Okay. We get to pick which trig function we're going to use. So I'm going to circle 50. That's my angle. And 20. The other thing that they give me is the what side? Adjacent. What is H?
Opposite.
Opposite. So I don't know anything about the hypotenuse, but I don't really care. I want to use the trig function that is O and A. Which one is O and A? Tangent. Okay. Tangent of what? 50 equals? Yep. H, opposite over adjacent, H or X over 20. Okay. How do I get H by itself? Multiply 20. Now, many of you guys are going to do that correctly, but you're going to get the wrong answer. And you know why? Because your calculator might be in radians. You need to make sure your calculator is in degrees. Why do you need to be in degrees? 50 is 50 degrees. This is a degree measure.
How do you change that again?
Go to mode and go to radians, degrees, flip it to degrees. Okay? That's why it's so important to check and make sure your answer seems reasonable. If you would be in radians, you would probably get an answer that just like does not even make sense, right? 20 tangent to 50. Try that and tell me what you get. It should be a number that's a little bit bigger than 20.
23.83507.
We'll go 23.8. How about that? How did I know that that was going to be bigger than 20? Anybody have any ideas? Okay, if this is 50 degrees, what would this angle up here be? 40. And 40 is opposite 20. And 50 is opposite this number, so I know that number has to be bigger than 20. Does that make sense? Like that's one thing you can check to make sure, like, oh crap, was I in radians or degrees? Does the answer make sense? Because if you're in radians, it probably won't. Okay, got it? There you go. 28.3, whatever units we're in. Feet, what it doesn't say, but got it? Questions about that?
Nope.
All right, let's go on down. Solve triangle ABC. Huh. Okay, when it says solve the triangle, that means find everything. So some of these things we know already. I'm just going to write ABC and ABC. And I'll just fill in all of the things that I know and I don't know. Okay, so you really only have to find the ones that you don't know. But I'm just going to list all of them. A, B, C, and A, B, C. Okay? All right, we know over here, we know capital C is 30 degrees. And I know lowercase a is 1. What else do I know? Capital B is 90 degrees. And then from there I can find what capital A is.
Ours says 10 for A.
What are you talking about?
Our paper. James.
James!
So random.
Why did you?
He's such a little trickster. Okay, capital A. So those are the things that I'm given. Capital A is what? 60, right?
Oh.
Okay. These two have to add up to be the other 90, correct? Okay, so now I have all that stuff. Now we have to decide what we want to do. I have 60 here, 30 here, 90 here, A is 10. Which one do you want to find, B or C? C? Sure. Do you want to use 30 degrees or 60 degrees? It doesn't matter. Neither of them are rounded. You want to use 30? Okay. So 30, and we know 10, and we know C. Okay, so we're going to use those three things that I've outlined in black. If we're using 30 degrees, what is C in relationship to that? Oh, what about 10?
Adjacent.
A, we want to use sine, cosine, or tangent? Tangent. Tangent of what?
30.
30? Okay, do we need to be in radians or degrees?
Radians.
Why degrees? Why degrees? 30 is a degree, right? Okay, most of the time you're going to want to be in degrees because, you know, that's the way it works.
I just switched it.
Opposite is C, adjacent is 10,
So
and I'm
10
going to multiply by
times
10.
10, 30.
10, tan, 30. That is C.
5.77.
5.77. Got it. All right, let's use a different one to find B. We could do the Pythagorean theorem if we want to, but
But we don't.
why don't you want to?
Rounded.
Yeah, 5.77 is a rounded number, so it'd be better to do a trig function. Like you're going to get about the same answer, but it would be better to do a trig function. So we're still going to use the number 10. Let's still use the 30. But now we're finding B. So now I'm looking at the three things that are in blue. This is still adjacent, but B is the hypotenuse. So I want A and H. Which one's A and H?
Huh? Oh.
Cosine. Cosine of 30 equals A is 10, H is B.
Awesome.
Now, how do I do it when the B is in the bottom? I switch those two around. So B will be equal to 10 over cosine 30. Do you remember how to do that? If the B is in the bottom.
Is it inverse?
What?
Oh, is it reverse cosine? Or
No,
the-
no, it'll just still be like,
Divide?
but it'll be 10 divided by. Instead of 10 times cosine 30, it'll be 10 divided by cosine 30. Okay, because cosine's down in the bottom. So you don't have to do anything with 11.54?
5.5.
547.
11.55?
Yep.
Sure. Okay, let's see if that makes sense. Just looking at these numbers. The biggest angle should be opposite from the biggest side. Yeah? Is it? The smallest angle should be opposite from the smallest side. Is it?
Yep.
Yeah. Okay, that should make sense. Good, good. You could also check these and make sure that that makes sense in the Pythagorean theorem if you really wanted to check, right? Like those should be about the same. Okay, if you're really like messed up and you want to make sure. Okay, all right, let's go over here. I like this problem because we don't know any angles. This is kind of interesting. All right. We know little a is 3, little c is 7. Is that correct? Or is it wrong on my sheet? Okay, that's correct. B, capital B is 90. All right. I know little a is 3, little c is 7. What would you like to find first? Let's find little b. Let's do the Pythagorean theorem for this one because 3 and 7 are not rounded. So we can find little b. 3 squared plus 7 squared equals b squared. Now this is confusing because I always think c is my hypotenuse, but not according to how they label it here, right? Okay, this is 9 and 49, which is 58.
I had that wrong.
Is that true?
Yeah.
The square root of 58? What's the square root of 58? Go ahead and give it to me.
It still came out, right?
Like, go ahead and do the decimal.
1577.
7.62? We'll go 2 decimal places. 7.62. Let's do that. Okay, now let's use a trig function to find a. So I could use 7.62 as one of my sides, but it's rounded. So we want to go back to using the 7 and the 3. Let's find a first, okay? So those three things that I have circled, those are what I'm using. What is 7 in relationship to side A or angle A? He is the adjacent. Okay, what about 3? Opposite. Okay, which one uses OA? Tangent. Okay, tangent of what? What are we taking tangent of? What?
90.
No. We're taking tangent of angle A. We don't know what A is. Tangent of A is the opposite side is 3. The adjacent side is 7. Okay, now how do I get the A out of there?
This is the inverse.
This is where we take the inverse tangent, right? Inverse tangent, because that cancels them over here, but we have inverse tangent of 3 over 7. Okay, now do you want to be in radians or degrees? It depends on whether you want A to be in radians or degrees. Do you want A to be in degrees? Yes. Okay, A is how many degrees?
My
23.2.
23.2.
23.2 degrees. Okay, now we can use that to find C. We'll go ahead and just use that number, right? I know that A and C added together are going to be 90. So 66.8. Perfect. There you go. Okay, now is the biggest angle opposite the biggest side? Is the smallest angle opposite the smallest side? Yep, we're good to go. Okay, happy with that? The only time you use inverse tangent, inverse sine, inverse cosine is when you're finding an angle, right? Only time. All right, here we go. We need a picture. You need to draw a picture. A pilot in a plane at an altitude of 22,000 feet observes that the angle of depression to a nearby airport is 24 degrees. So here's my airplane up in the air. Okay, and it is 22,000 feet in the air. Okay, now here's the deal. Here's the airport. I'm doing a little building there. And the angle of depression, this is where people get confused. Angle of depression is from horizontal down. Here's what an angle of depression looks like. So if I were to keep going in the airplane, I would be zipping right along, right? The angle of depression would be, this angle is 24 degrees. Does that make sense? The angle of depression down is 24 degrees. So when I actually make my triangle out, 24 degrees is not the angle that's up top here. That's what a lot of people think. But depression is from there down, okay? What will that angle be? 66 degrees. Okay, they are wanting to know how many miles is the airport from the point on the ground directly below the plane. What are we looking for? This distance here, directly below the plane, and they're wanting it in miles, but the problem is our 22,000 is in feet, so we'll convert here in a second, right? Okay, all right, how are we going to start this? 66 is my angle. I always look at the angle first. Okay, they give us 22,000 feet. That is the adjacent. You can convert now if you want to. I'm going to wait till the end. A is that guy. We are wanting to know the opposite side. Okay, so which one's AO or OA? Tangent. Tangent of what? 66 equals opposite, which is X. We don't, whatever you want to label it, over 22,000. Okay, then if I multiply by 22,000 over, X is equal to, what is it, whatever that is. Do we want to be in radians, degrees? Because 66 is a degree. 49412.8. And that is in feet, okay? Yeah, leave it in degrees. 90% of the time you're going to want to be in degrees. Okay, 49412.8 feet. I want miles. How do I convert that to miles? What? Divide by what?
Divide by 5280.
5280, because there's 5,280 feet in a mile. And 9.36 miles. 9.36 miles. Okay, Jayton asked just a minute ago, she goes, can we convert the 22,000 feet to miles first and then leave it? That's fine. You can do that. Yeah. I would just like to take like tangent and stuff of a clean number rather than, so you can convert at the beginning and you're going to get just as accurate of an answer. Okay, so 9.36 miles. Got it? Okay, conversions between radians and degrees. What's the conversion? It's either pi over 180 or 180 over pi. Why 180 and pi? Because 180 degrees is pi, right? So we're multiplying. Pi divided by 180 is equal to 1, right? Those two cancel out with each other, okay? So that's why we can get away with doing this, all right? We're going from 11 pi over 5 radians, and we want to convert him to degrees. So which one do you want to use out of these two?
180 over pi.
We want to use 180 over pi, so the pi's in the bottom. So 11 pi over 5 times 180 over pi. Okay. You do not want to have a Well, I guess in this one it doesn't really matter. Decimal.
This is going to my table.
Sure. Okay, now what?
You cancel. Now you just solve it.
Now you just solve it. You could reduce the 5 and the 180 if you want to, or you can just take literally 11 times 180 and then divide that number by 5. How many degrees do we got?
396.
396. Okay, you people who like Kyle's method. 11 pi over 5. 2 pi, which is equivalent to 360 degrees, would be 10 pi over 5. We're looking at 11 pi over 5. So we're looking at a little bit more than 360 degrees, which is what we have. Okay, good? All right, you do number 8. Go. And I'll catch up with you. You do number 8. Go. I'll give you like a 15-second head start, and then I'll go. Plus 35 is 350.
Ah, you did that.
I don't know if that's right.
Yeah, that's fine.
Should be
Hey!
negative though.
Is it negative?
Yeah.
Should be.
You.
Right? Negative 315? Yeah. Yep, the negative just gets slapped on the end. Don't forget that.
What? Fix your angle, please, child.
What are you talking about?
Make him positive. Make him look.
No.
How did I do
Nope.
that? Because I didn't reduce.
What you talking about?
don't
You
have
just
to
took
do
7 times 180 divided by 4. That's the same thing. I
did.
just reduced it because I can't
I did do
multiply
that.
those big numbers in my head, so I reduced it first. It didn't matter. It didn't matter. Okay, happy with that? That's number 8. Let's go to number 9. This is a degree, and I put him over 1 to make him a fraction. We want to multiply this one by pi over 180. Now, here's the deal. I don't want you to give me decimals at all. No decimals. Are you listening to me? No decimals. Cross off the degrees. The pi is going to stay in your answer. What else can I do? Cross off the zeros. I can knock a 0 off. 4 and 18. Can I reduce those?
Yes.
2 and 9 if I divide by 2. So the answer is?
2 pi over 9.
That's it. 2 pi over 9. Do not give me a decimal for 2 over 9. Give me 2 pi over 9. Because 2 over 9, did you know, is 0.2 repeating. And if you just say 0.2 pi, this is technically less accurate of an answer than 2/9. Does that make sense? So I would rather have the fraction than the decimal because the decimal is going to be rounded. Got it? Okay?
Yes.
Okay, number 10, you go. Oh, I gotta think
Why
now.
are you typing so loud?
What?
Huh?
I got 35.
If you convert it so it's
35.
nice, so therefore
No.
85 degrees.
You be quiet.
What? Why would you not want to be nice?
You're not nice.
We like you and you're nice.
I don't understand 12.
I was waiting for somebody to say that. Is it negative?
Yeah.
Don't forget it.
Depends.
12?
Yeah.
What'd you get for 12?
Negative 35 pi over 36.
That's what I got.
Got it? Happy with that one? That was number 10?
Oh, it's
We're almost done.
degrees,
Woo!
so it has a different thing.
Okay. All right, here we go. Let's look at what we're talking about here. 0 and 2 pi is what we want our number to be between. Find a number theta that lives between 0 and 2 pi. 21 pi over 5 is way bigger than 0 to 2 pi. Like that would not be on my unit circle even if it was. Like we don't have 5s on my unit circle. But anyway, even if it was, it wouldn't be between 0 and 2 pi. 21 over 5, if I reduce those numbers, this is 4.2 pi. I want it to be between 0 and 2 pi. So what do I do to the 21 pi over 5?
Add 10 pi over, or subtract 10 pi.
I'm going to subtract 2 pi. You either add or subtract 2 pi or add or subtract 360, right? Okay. I'm going to subtract 2 pi, which Jalen says is 10 pi over 5, right? 10 over 5 is 2. Okay, if I reduce that, or subtract that, I get 11 pi over 5. Is that number going to be between 0 and 2 pi?
No.
Crap, so what do I do now?
Do it again.
Subtract another 10 pi over 5. And that's going to be 1 pi over 5. Is 1 pi over 5 between 0 and 2 pi?
Yep.
Sure, 1/5 right here. Like 1 pi over 5, 1/5 is 0.2. And 0.2 is between 0 and 2 pi. Does that make sense as a decimal?
Yep.
Right? So pi over 5, what is pi over 5 in relationship to 21 pi over 5? They are coterminal. It's like 2 less circles around. Right? This is like 2 and 2, a little bit over 2 circles around. This is only just a little bit of a circle. Right? That's 11. Got it? 11. Okay? 12. This is negative 25 pi over 3. 25 over 3 is 8 and like a third. So 8.3. This is negative 8.3 pi. That is way bigger than 2 pi. Actually, way smaller than 2 pi because it's negative. Sure. What do you want to do to this?
Add 6 pi over 3.
Okay, I add 2 pi because it's negative. So add 6 pi over 3, and I just keep doing that, right? If I add 6 pi over 3, I get negative like 19 pi over 3. Okay, let's add 6 pi over 3 again. This is negative 13 pi over 3. Right? Am I doing this right?
Yes.
Okay, add another 6 pi over 3. That is negative 7 pi over 3. Quit distracting him. Add another 6 pi over 3. That is negative 1 pi over 3. Add another 6 pi over 3. 5 pi over 3. Are we finally between 0 and 2 pi? Yes. 5 pi over 3 is between 0 and 2 pi. Okay. 5 pi over 3 is on my unit circle. Okay. Got it? Good? 2 left. Boom. All right. Number 13. Through how many radians? Circle that word.
I don't like this.
How many radians? Does the second hand of a clock move in 2 minutes and 20 seconds? All right, so here we go. Let's talk about the 2 minutes part first. Shh, boys, knock it off. Jake, turn around. Quit touching him. I know it's really tempting or something over there. I don't know. 2 minutes. This is saying 2 cycles around. 2 complete circles. 2 complete circles equals how many radians? Okay, how many radians is 1 complete circle? How many radians is 1 complete circle? What? 2 pi, right? 1 complete circle is 2 pi radians. 1 circle. I cannot spell circle. 1 circle equals 2 pi r, right? 2 pi radians. So 2 complete circles would be 4 pi, right? That's what 2 complete circles is. Okay, now we got to do 20 seconds. So 20 seconds is what fraction of a circle?
1/3.
Yeah, that's 1/3 of a circle. Okay, so
120 degrees.
if no, we don't want degrees. We want radians. Okay.
120 degrees is.
All right. So what's a third of 2 pi?
2 pi.
What does the word of mean? A third of 2 pi.
It is.
Times 2
60
pi.
degrees. 2 pi
What's
over 3.
1/3 times 2 pi?
2 pi over 3.
I don't know where my pi went.
No, just do the thing.
2 pi over 3.
2 pi. This would be 2 pi over 3.
2 pi over 3.
So 6
Yeah.
pi.
Okay.
Wait, no.
So
120.
I am taking 4 pi and I'm adding to that an additional 2 pi over 3.
8 pi over
Okay. All right. 4 pi over 1 plus 2 pi over
3.
3.
Wait, no, 14 pi over 3.
If I get a common denominator, that is thirds. What is 4 pi in terms of thirds?
12.
12. What's 12 pi over 3 plus 2 pi over 3?
14 pi over 3.
14 pi over 3. That is my radians. Okay. I just dissected it down into 2 pieces. Do we understand how that works?
Yeah.
A third of a circle is going to be 2 pi over 3. 2 full circles is 4 pi, and you add them together and find a common denominator. Questions about that? No. Okay. Revs per minute. This is the process of finding the angular speed. The angular speed. Okay? They want 12 revolutions per 1 minute. Okay? And they want it to be converted to radians per minute. Okay? So I need to convert my revolutions to radians. So I gotta put revolutions on the bottom. This is just a unit multiplier or a train track thing.
You know that 1 rev is
One
2
rev.
pi.
Is 2 pi radians. Okay, if I cancel my revs off, now will this thing be in radians per minute?
4 pi radians per minute.
Yeah, this is 24 pi radians per minute. That is like literally the angular speed. So,
Easy peasy.
easy peasy. You're just doing a conversion, angular speed. So that thing is moving at 24 pi radians every minute. Got it? Easy peasy. Easy. Okay.
Congrats in there.
Good? All right, tomorrow I will record for you some whiteboard problems with the solutions. What I anticipate for you to do is I will list the problem out and then I will solve the problem, but I would love for you to like be pausing in between